The vectors I and j are unit vectors in the positive, horizontal, and the positive vertically upward directions, respectively. Forces P and Q given in newtons by P is 12I plus 5J, and Q is 8I minus 7J. A particle is in equilibrium under the forces 2P, KQ, and its weight W. Find the value of K and find the mass of the particle. Now, in order to start this, you should draw some sort of diagram. Don't have to be exact. So here's my particle. I'm going to put this is the I direction, J direction. And as P is 2P, this will definitely be acting in this sort of direction. So I'm going to write that 2P is 12I plus 5J. Now, the problem with Q is that we don't know what the value of K is, but assuming for it to be in equilibrium, it must be somewhere in this sort of direction. So I'm going to just draw it. If it's not right, it doesn't matter. So KQ is equal to K times 8I minus 7J. And then we have the weight acting downwards, which is mgi. J, sorry, not I. Okay. Right, so now we can start to resolve to find K. So the system is in equilibrium. So that means that the I components would have to balance each other out, and the J components would have to balance each other out. There's no I component in the weight. So resolving in the I direction, so just considering the I components, we've got 2 times 12 plus 8K. We have to put plus because we don't know what actually K is equal to 0 because it's in equilibrium. So that will give 8K is minus 24, and that K is minus 3. Like I suspected, it would have to probably be negative for the I components to balance each other out. Okay, so redrawing the diagram again. You don't need to do this, just so that we can actually see it. Right, so we're now going to resolve in the J direction, just looking at the components only. So we're going to be looking at these components here. So we've got minus 3 times minus 7, minus 3 times minus 7, plus 2 times 5. And this one will be acting against the J direction, so this will be minus mg, and that will be equal to 0, which means that mg will have to be 21 plus 10, which means that m will be 31 over g, and that gives me an answer of 3.163, which is 3.16 kilograms. Okay, so this has been a video to show you how to find a constant and the weight of a particle which is in equilibrium using vectors. I hope you've understood, and I thank you very much for watching.